Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0111, signifies an issue with the intake air temperature, IAT sensor circuit, specifically indicating a range or performance problem in Honda Accord models from 2012 to 2017. The IAT sensor is crucial for determining the temperature of the air entering the engine, as this impacts fuel delivery and overall engine performance. In instances where the sensor fails or delivers faulty data, the engine control unit, ECU, may operate inefficiently, resulting in various performance issues. This trouble code can appear as a confirmed or pending status, and it's vital to understand that proper diagnosis is crucial before any repairs. The troubleshooting process aims to accurately identify and rectify the underlying causes to ensure the vehicle runs effectively and efficiently. The IAT sensor is responsible for measuring the temperature of the incoming air to the engine, which aids the engine control module, ECM, in determining the appropriate air-fuel mixture for combustion. This sensor plays a pivotal role in optimizing engine performance, efficiency, and emissions. It is typically located in the air intake system, closely associated with the mass airflow, MAF sensor. Both sensors are crucial components located near the engine's air intake, pivotal for accurately reading air temperature. Incorrect readings from the IAT can lead to poor engine performance, increased emissions, and reduced fuel efficiency. Therefore, addressing any performance problems identified by DTC P0111 is essential for maintaining the vehicle's reliability and responsiveness. Possible causes for DTC P0111 revolve primarily around wiring and connection integrity, as well as sensor functionality. Poor connections at the IAT sensor, MAF sensor, or engine coolant temperature, ECT sensors, can impede the proper signal transmission to the engine control module, ECM. This might involve loose terminals or corrosion at the connectors, which can alter sensor performance and readings. Additionally, a faulty IAT sensor becomes a prime suspect when the PCM detects irregular or erratic input values. Furthermore, the failure of the MAF sensor may also contribute to erroneous IAT readings, significantly affecting engine management. Each of these conditions needs careful examination during the troubleshooting process to isolate and resolve the issue effectively. Symptoms associated with DTC P0111 may vary, but generally center around engine performance and operational efficiency. Drivers may experience noticeable declines in engine performance, such as sluggish acceleration or reduced power, resulting from improper air-fuel mixture due to faulty IAT readings. Often, the vehicle may illuminate the check engine light on the dashboard, serving as an indicator to inspect the engine management system. Another prevalent symptom includes increased fuel consumption, where the engine may compensate for incorrect air temperature readings by delivering more fuel than necessary. These symptoms can significantly affect the driving experience and necessitate timely diagnosis to prevent further complications. The first step in troubleshooting DTC P0111 involves conducting a thorough visual inspection of connectors related to the IAT and MAF sensors and ECT sensors. This step is crucial as poor connections or loose terminals can significantly affect signal quality. Inspect the MAF IAT connector for signs of damage or corrosion, which can lead to intermittent failures. Ensure that all connectors are securely attached and terminals are clean and free from debris. If this inspection reveals no issues, proceed to the next troubleshooting step. However, if any problems are found, repair the connections before moving forward, as this could directly affect sensor performance. Step 2 involves a performance check of the IAT sensor at low temperatures. Begin by removing the MAF sensor, IAT sensor, and allowing it to cool down to the ambient temperature. This step ensures that you obtain an accurate reading from the sensor. After it is cooled, connect it back to its 5P connector, but do not reinstall it. Next, turn the ignition switch to the on position, or press the engine start-stop button to select the on mode, which activates the sensor electronics. Utilize the Honda Diagnostic System, HDS, to quickly note the IAT sensor value in the data list. Compare this value with the ambient temperature noted earlier. A difference of 5.4 degrees Fahrenheit, or 3 degrees Celsius, or more indicates a fault, necessitating the component's replacement. If the readings are within range, the troubleshooting will advance to the next stage. The third troubleshooting step focuses on assessing the IAT sensor's performance at high temperatures. First, turn the ignition switch to the lock position, or select off mode to ensure all electrical components are powered down. Disconnect the MAF sensor, IAT sensor 5P connector before proceeding. Using a heat gun, apply hot air to the sensor for a brief period, ensuring you do not exceed a few seconds to avoid damaging it. Once this is complete, reconnect the sensor to its connector without reinstalling it. Turn the ignition back to the on position. Monitor the IAT sensor value using the HDS. A significant change of 76 degrees Fahrenheit, 42 degrees Celsius, or more indicates that the system is operating correctly, but check for potential intermittent failures. If the sensor does not respond adequately, it will require replacement before completing the repairs. Once the necessary repairs have been completed, it is critical to conduct a thorough repair verification. Start by turning the ignition switch to the on position and resetting the powertrain control module, PCM, using the HDS. This reset is essential to clear any learned parameters related to the faulty IAT sensor, allowing the new data to be evaluated. After resetting, perform the PCM idle learn procedure to ensure that the engine management system correctly adapts to the changes made. Finally, check the system for any remaining pending or confirmed DTCs using the HDS. If DTC P0111 is still present, return to the initial troubleshooting steps, focusing on connection integrity and sensor functionality to identify lingering issues. In conclusion, DTC P0111 highlights an essential issue within the IAT sensor circuit that can have significant implications for engine performance and overall vehicle operation. Understanding the role of the IAT sensor, along with strict adherence to the detailed troubleshooting steps outlined, is imperative for effective diagnosis and repair. Each step, from visual inspection through sensor performance validation, should be meticulously executed to ensure correct operation and performance yields. Maintaining the integrity of electrical connections and sensor functionality is not only critical for resolving the current issue, but also for the long-term health of the vehicle's engine management system. By addressing these elements thoroughly, you can restore optimal engine performance and enhance driving efficiency. Please like and subscribe to the channel. See you next time.